In the following video lecture, I will give you a brief introduction into a parametric modeling workflow for furniture design. I will break up this into three modules: explorative modeling, refining the design, and creating components and drawings. We will obviously continue what we have learned from the previous parametric sketching video and now focus more on the 3D modeling aspect. As a study object, we will recreate this wooden table. So let's get started. So I will create a new design. So this is an empty document. The problem every designer has when you start working in CAD is, and that's the reason why I call this module also explorative modeling, you might not necessarily really know your full design. You can use CAD in two ways. You can use CAD to build something based on a blueprint you have, or you can use CAD as an extension of hand sketching. I maybe could call this one three-dimensional sketching. So we explore a design. So the whole process I'm going to show you is not a process that is based on creating the 3D models which are based on finished blueprints, but more I will show you a process where we explore ideas and then afterwards create all the blueprints based on what we explored. So we have a table. We have basically three building blocks. We have the tabletop, we have the table legs, and then we have support structure. And you might remember from the video where I showed you introduction into sketching that we have to create a sketch from which then we can extrude or create three-dimensional objects. So let's start, for example, with the tabletop. So I will rotate my view a little bit and I will switch to inches. Let's zoom out a little bit. And I could now create a sketch on the ground plane, but we don't have a tabletop on the ground. The tabletop is actually 29 inches off the ground. But you see, by default, I only have three planes to orient actually my sketches on. If I go to this origin folder, you also can see here I only have three sketches. So what I would have to do first is actually create a construction plane at a height of 29 inches away from the ground, so that on this construction plane I can position my sketch and then create the drawing for it. So when you go to construct, that is where you can create all those different construction planes. For example, we can do a straight offset, we can make a plane at an angle, we can make a plane that follows a path, or a plane that goes through an axis, etc. What we need to do is actually offset the ground plane simply 29 inches along the z-axis. So the offset plane is the command we want to use. And you see those planes are gone because the origin is turned off. If I turn this on, I can see all these different planes. Now I can click on the ground plane and then drag this one up, or I can simply, since we are in inches, type in 29. I have to zoom out a little bit, and that is now the sketch at a height of 29 inches. Click OK, and you see in the browser it creates a new construction folder with plane 1. Let's right click and rename it. Or just click on the name there, and this is actually very good practice. All these sketches and construction planes, you want to give proper names so that later when your design is more complex, it's easier to navigate the browser. So we call this simply tabletop. I don't have to add construction plane because it is inside the construction folder, so obviously this is a construction plane. Perfect. Okay, I can click on create. This construction plane was actually selected. And I just wanted to show you that you see the sketch will be created up here. This is actually the world X, Y, and Z 0 point. So you see the sketch will be created somewhat 29 inches above the ground. This is good actually to go into top view, and now I can go to line and, for example, just create some sketches or some lines, close it. This is all not really dimensioned and it all doesn't fit yet, because that is what we're going to do in the next step. So we can press D or go to dimension and, for example, add our linear dimensions. So this should be maybe 63 inches and this should be 31 inches. It's kind of like my computer table. And you see this rectangle is not centered on the world, which is what I want. So I can click on the world point, click on, or this is not world point, sorry, this is actually the sketch point. You see this is actually on the sketch, so X and Y 0, this is actually the world point. So I used the wrong term, sketch center point. And then let's say maybe this line, and drag out this dimension, double click, click this one, and then divide this by 2, because this is then half of 63. This one and this one, double click, click this one, divide it by 2. And when I say click, it's basically left mouse button click. Okay, so this is now our tabletop. Perfect. Now, for example, we could say, let's create the tabletop. So I can click on this one. The tabletop is maybe 1 inch height. Okay, good. Every time when you create a sketch and then you create a new object, so a three-dimensional object from it, by default the sketch will be hidden, so I have to reactivate this one. This one here now says sketch 1, which doesn't really tell me much, so I make a very slow double click. So now quick double clicks, but click, click, then you can rename it. I call this one tabletop. And again, because this is inside the sketch folder, obviously that's a sketch. Now let's say we would like to adjust the height of the tabletop. Maybe not 29, let's say maybe 30 inches. This might be a good opportunity to explain again also the way how the timeline works. So you see here's my three-dimensional object, which is based on the sketch, and the sketch is positioned based on the construction plane. Each object you can double click and then you go into the individual edit mode. So if I want actually to move my tabletop down, I could, for example, say move this tabletop down maybe by -1 inch. But this doesn't necessarily really make sense, because I define where the tabletop should be, I create a sketch, then I create the three-dimensional object, and then I move it down. So in our case, this is not very logical, because I should simply define the construction plane exactly at the height it really has to be. So right click, edit feature, or double click, left mouse button, and then for example there I set this simply to 20 so you can see the difference. And you see this construction plane was changed, so that means the sketch will move with it, and that means the three-dimensional object will move with it as well. So you see this is all chained or interactively connected to each other. It's basically what parametric modeling is all about. Okay, so the tabletop, let's say, is done. Now we would like to create the legs. I could create, or I could add the geometry of the cross section of the table leg, let's say it's a 3 by 3 inch wooden element, right into the tabletop sketch. I personally try to really keep the sketches in general very clean. So if I have a sketch for one object, it ideally should only include that. Plus, it's much easier to say, well, the legs start at the ground and grow up towards the tabletop, because there's actually a function to it to say that the legs should go a certain distance till they meet a different object. So what I will do is actually I will create a new sketch for the legs on the ground. So this time I don't need to offset any construction plane, because I can simply use the construction plane that is on the Y and X axis, so on the ground. Click. Perfect. I could hide this one. Maybe I want to hide this one. But let's say I want to be able to also say, well, so if I add the sketch for the leg cross section, it should also have a, let's say, a 2-inch or 1-inch distance to the edge of the tabletop. But you see, the problem is that where I will create the rectangle, so let's maybe quickly create a rectangle there. I use the grid for the moment there. So how do I make sure now that this distance is exactly the way how I want? Because the problem, as you can see, is these two-dimensional sketches are not even really on the same plane. Plus, these are actually two different sketches. And in parametric modeling, what you can do, you can reference one sketch to a different sketch, and either by making this making three-dimensionally the sketch snappable to, or what we will do is we will actually project two edges of the tabletop sketch into our leg sketch. So what I will do first is I press escape and let's rename this one. So this is table leg. Okay, great. So this edge and this edge I somewhat need to be inside my table leg sketch. So I can create two-dimensional dimensions or relationships. So what I will do is go to sketch, go to project, and project basically means I'm inside editing the table leg sketch, and everything I will click on will be projected down right onto the sketch. And you see, when actually I move my mouse over these lines, you see there's a red dot right there popping up. This will be easier viewable here. You see there's a red line. So click and click. So these two edges I project down. Click OK, we're good. So what I did was actually taking this edge and just interactively projecting it down. So this edge I can't really work with, but I can snap to. So when I say I can't really work to it, so let's say I show the dimension, I can't really select this point and move it because this is interactively projected down. But if, for example, I set this to 60, you see this line updates. I hope this actually starts to make sense, what I mean with parametric, that I reference to something, because those two-dimensional constraints only work well in 2D. So the sketch is somewhere above 29 inches. I need to create something I could sketch to. I could create a dimensional constraint to. So that's the reason why you project it down. Okay, so next step would be, I don't really move this one closer. I simply create a dimensional distance between these two lines and say 2 inches and then from there to there with the dimension tool, 2 inches. If I go to top view, and you see now perfectly everything is dimensioned. Okay, stop sketch. And again, the way how everything works and the whole goal is, because in parametric modeling everything is honestly like playing with Lego, but just for 3D design. Everything has a certain logic, and the idea is how can you combine all these building blocks to create the outcome you desire, and also be able to establish relationships you could adjust. So for example, if I type in 60, everything updates. So I do not only update my tabletop, but I also, because of the relationships, I updated the position of where my legs only should be. So you see that this is a very big time saver. Imagine you have a table with, well, all the other 3 legs, so 4. If I change the tabletop and then I have to reposition each leg individually, it's a lot of work. And here it's basically changing a number for the tabletop, and the rest is done automatically. And more important, it's done precisely. Okay, so now we have actually the sketch for the leg. Now you might ask, well, what's up with the other 3 legs? I could create that sketch obviously as well, so adding all these other 4 parts, but it's not really necessary, because in our design the table leg is a copy, so they're all the same. So I could rather build the leg one time and then mirror it over along the y and the x-axis, which is why I wanted to, with those constraints, make sure that the tabletop is nicely centered on my world. So let's actually extrude this leg out. So let's go back to extrude. I can click on this filled area. And there are 2 things now I could do. I could say, well, this should be 29 inches only, because, well, the tabletop is at a height of 29 inches. Okay, good. But let's say at one point I say, this should be at, let's say, 35. Oh, well, my leg isn't long enough, so I have to go back and adjust the leg. Possible, not really good. So what I could do instead is actually I can establish another relationship. So for example, let's bring this one down. I could, for example, say here distance. That's basically the distance I can define how far I want something to be extruded, or with 2, I can tell the software will extrude the sketch till you hit another object. So 2, for example, there. So I clicked on this area. Click OK. And now when I go to here and say maybe 30 again, 35, you see the leg updates, because this extrude function I didn't give a static value of 29. I told it basically extrude as long as you hit the tabletop. So let's go back. Let's make this 29. Good. Before we continue, there's one thing I want to also point out. You see inside bodies, we only have 1 body left. So what happened? Well, what happened was actually when we extruded this leg out, let's double click it. There is an operational function. So I could say join, which actually is what happens by default. So the leg will be extruded and then joined with the tabletop, which however is not what we want. We could say cut. So for example, if it goes through, it cuts a hole. What I want is create a new object, so a new body. We have to select this as an object, as an option for the operation. Click OK. And there we are. Now you see we have 2 legs. I mentioned to you it's really good practice to name all the different sketches and the constructions, but I didn't really talk much about the bodies. The problem is you can give them names, but sometimes we calculate bodies together, and that basically will change the amount of bodies and then we change the name of the bodies automatically. So I actually don't bother giving the bodies names. Maybe at the end of the final design, then I actually start maybe giving them names. But most important, it's really I find it most useful to give sketches and constructions a name. So let's go back to our single table leg. It looks pretty lonely, and this table will not be very functional with the 3 legs missing. So how do we do this? Well, one could say copy and paste and move, but this is way too complicated, way too much work, and also it's prone for errors. So we will actually mirror it over. The mirror function you can find here under Create. So you want to select an object. Here we have different types, so pattern face and pattern body. Body is what we want to select because this is a body. Select the leg, click on the plane selection field. We want to select this one, click OK, and you see it mirrored over. Now we have to do one more time. You can actually, whenever you want to repeat something, right click and then drag the mouse up. So if you want to get used to the context menu, so repeat mirror, select this one, pattern bodies was already selected as a type, click select, and now we have to select the other plane. And there you see they're mirrored over. Click OK. Good. Now taking a look at this one, my legs actually with 4 inches now looks pretty heavy, so I don't really like this. So I will actually show my dimensions for the sketch. Take a look at it. And I did not really have any dimensions for those lines, so double click so we can add some dimensions. So for example, press D, dimension this one, dimension this one, and then it's up to you which one you select. I want them always to be symmetrical, so double click, click this one, because this line should be the same like this line. I don't have to divide it or so. I simply press enter and you see the function is 4.0. Now if I set this one to 2, you see this function updates as well. Stop sketch, and you see all legs are updated. How beautiful. So let's add some more elements that will make this table a little bit more stable. So between those legs and under the plate, I would like to add some crossbars. So there are multiple ways how we could create these crossbars. I could, for example, create the information for the crossbars and include it into the tabletop and then extrude it down. But I would need to figure out where to draw it so that actually it fits right between the legs. Too complicated. But I can actually also create a sketch, as you can see, on the face of an object. The cool thing with that function is I can then position a sketch on the face of an object, and the sketch, when the object moves or adjusts, moves as well. So it's up to you which one you want to select, doesn't really matter. I will work with the left one. Click on this face. For the moment I will hide all objects, and there you see now I created a new sketch, and this yellow object represents the face of that leg. So maybe in this case now let's create maybe a crossbar with the rectangle tool. Okay, perfect. Press escape. This one I want to move up and maybe snap to there till it hits this edge, and you see that it actually added another constraint. That is the coincident constraint. This means that this point actually will always slide along this edge, and now I moved it to the midpoint, so it added automatically also the midpoint constraint, and I can't move this one anymore. So I have to delete this constraint, but now I can slide this one around. And you see this one I can slide left and right, but I can't move it down because this point is part of this edge. This edge is set to be horizontal, and this edge other point is set coincident to this line. Okay, this is exactly what I want. Now how do I best kind of like dimension this one so it's nicely centered? Well, first let's maybe dimension this plank. Ooh, this is not 1 inch. There, 5 inches down, 1 inch material thickness. That is good. Okay, so if I click this edge, it actually reads out this line I selected, and it tells me that this is actually 2 inches long. So essentially this has to be 0.5 and 0.5 inches. No, 0.5 is 1 plus 1 makes 2. So I could say in this case this edge and this edge be 0.5 inches. Now this is 0.5 and this is 1. The problem, however, is how do I in the easiest way make sure that this edge will always be perfectly vertically centered under this edge? So this approach doesn't actually work really well in this case. Also, this one for the moment I have to remove, and then I move this one down a little bit. So somehow I want to say that this midpoint should be centered to this midpoint. And what I will do is I will create a small helper. I will add simply a point and a point here to this midpoint. You see I can snap to a point or the mid position on this edge. Perfect. So you see now this point is actually at the center or midpoint of this edge, and this point I can say position at the midpoint of this edge. So I go to the constraints, midpoint, this one to this edge there. Now whenever I adjust basically those two lines, so to make currently it's a 2-inch block, maybe I make it 3-inch block or 4-inch block, this 1-inch rectangle will always be centered. So now we can stop the sketch and maybe turn back all our objects. Maybe let's call this one, this is support short, so the shorter edge, or left or right, based on how you want to name it. We can extrude exactly only this part. Also here, we set this type to 2, rotate the view, click on this face, and then say new body. Okay, perfect. See, looks pretty nice. Okay, now we want to move this whole object to the right side as well, so there we will do another mirror modifier or feature. Select this object, select the plane selection. Now we select this plane, click OK, and there we are. Now again, right click onto support short, show dimensions. If we don't really like what we see, we can adjust this easily. And maybe 3 feels a little bit visually lighter. Okay, so now this we can actually apply to the other side of the leg, because this seems to be a good working system. So let's create a new sketch on this face. Let's hide everything for the moment. Then I will go again to the rectangle tool, or here 2-point rectangle. I can make a small one, and for example we can dimension this one and dimension this one. And now actually I would like the height and the width to be the same as in this other sketch. And the cool thing in Fusion is double click on this dimension and then click on this one. Press enter, and there it is. So you see, we can easily also make references to dimensional values of other sketches. Then we have to add the point there, and then midpoint and midpoint, and there we are. And you see everything is perfectly lined up. Stop sketch, and let's show the objects. Extrude this one out to this one. Okay, hold on 1 second. There, and new body. Perfect. Now we can again make a copy of this one along this plane. Good, and there we are. So to show you again why parametric modeling, in contrast to creating furniture in SketchUp, is simply dramatically superior, I adjust this height and everything else is adjusted as well. I'm not necessarily talking on purpose negatively about SketchUp. SketchUp is a pretty good program, but SketchUp was invented to quickly create some city plans with blocks. SketchUp was not really designed or invented to do serious design. Obviously, you can create furniture design in it if one wants to. That's possible, but it's not really the best work environment. And you see those adjustments I'm doing here by adjusting objects so easily, that's nearly impossible in SketchUp. And we just scratched on the surface of what Fusion can do. Also, everything I show you in Fusion is basically an industrial standard. So while we use Fusion as a design application, everything you will learn here you can also apply to any parametric solid modeler you might come in contact with, because essentially they all use exactly the same methodology. So last thing maybe I would like to add is on the left and on the right side, maybe a copy of the first plank a little bit lower. So the easiest way to do this is to see which sketch it is. So this is actually the support short. So I clicked too fast, click and click. This will be support long. Or inside the support short sketch, we will add the drawing for another element. And this should basically be the same. So we can go create a rectangle there. Now with the dimensional tool, so D, we can dimension this and this. Double click, click this, okay. Double click, click this, okay. And maybe we would like to adjust the distance between them. So maybe 3, or we could say, hey, this one be the same, the distance between these two be equal the height of a unit. So double click, select this one. Now the problem is this one is totally off. So with the vertical constraint, we can make an edge vertical, but we could also say this point and this point. They nearly look vertical, so the software will understand this as make them vertical. Perfect. So you see now pressing escape and adjusting this value to 4, everything nicely adjusts. Perfect. Okay, click OK. So now I could extrude this one out again, but I don't really actually have to do this because this sketch I created here. And then after I created the sketch, I created this object and then I mirrored this object over. So what I can do now is adjust actually this feature. So instead of extruding only this upper part, extrude both objects out. Obviously I could add now another extrude command, but it actually would just add more features inside the design timeline and make it actually later harder to read your timeline. Again, always try to take the shortest amount of steps to get exactly the creative result you want. So work smart, not hard. So double click on this feature because this is actually this extrusion feature. And you see here it says profile extruded one. Click on this one and now it extrudes too. Click OK and we're good. So now we extruded 2 objects at once, but only one object got mirrored over, so we have to do the same with the mirror command. Double click, and sometimes Fusion is a little bit picky here, so this one I delete and say you and you, or in this case now I needed to, on the Mac, press the Apple or Command key, and I think on Windows it's the Control key. I think if everything fails, we can also delete everything there and there. You see now I can just left mouse button click everything, click this one, and then say along this one, OK, and there we are. And again, how awesome if I adjust this one, everything here adjusts, including, as you can see, also those upper planks, the longer planks. Okay. To bring this first video, like explorative design, to an end, maybe this might be a good opportunity to introduce you to some modification commands. And today I will show you what the fillet does. So with the fillet or chamfer, we can break an edge. So it's nicer to touch. You don't cut yourself. Also, it will look nicer and softer. So I can select fillet, zoom to those edges, click on them with the left mouse button, click again, you see it deselects. And then either via the mirror move it in, because I know roughly the dimensions. This whole thing is 1 inch tall, the wood plate, so the radius can be 3 inches, maybe a 1/4 inch for rounding. Press OK. Perfect. There we have this one slightly filleted. Let's say we actually would like to round this edge as well. Well, we can double click this feature again, go to here, and then on the Mac hold the Apple key, or on PC the Control key. We can include those vertical edges as well. And you see you can even select through an object the edge. There. Now all those edges are rounded at the same time. But let's say you would like to have the side I selected here to be a bigger filleted radius and then have those smaller ones. So this set of fillets doesn't really work. So to create what I'm talking about, we have to do something like this. So I will select these 2 vertical edges first. there and there. And let's say, because this is now a vertical edge, an inch maybe, or maybe 2 inches. Okay, because again, we can adjust everything afterwards anyway. So now, because this vertical edge is now a nice rounded surface, I also have those arcs there. So when I go and say fillet and select this edge, you see a chain selects everything. So now here I could say 0.25. Okay, now you see I have all these other edges rounded as well. But maybe the first fillet is a tick too big, so I could easily maybe adjust this one to 1 inch. Yeah, this feels better. Okay. So what do we do with all the rest? So this is maybe our tabletop. I don't really do much with it, so I can actually name this one for a moment. There. Okay. So I have all these other edges I have to fillet. So there are 2 ways how I could do this. I could now at the end of the design timeline add all these fillets. So for example, fillet, say you, and all these others works. Or I could simply say, well, this is the first object I created. You see this time marker, I can move back to there because this object I mirrored over. So if after the extrusion I add now a fillet to it, so maybe also this is in my case D34. If I now say this 0.25, click OK, you will see that all those mirrored objects maintain the same filleting. So one command and it does all objects at once. Let's go to here. For example, there we can add some of these fillets as well. So maybe this one and this one. I will only select those fillets which the human eye can see, or basically you can touch. So these upper edges I do not fillet. .25, okay. But actually, which value was this one, or which name? D36. Okay, so here, double click, type in D36. There. Now actually it uses the value from this fillet to adjust this fillet. Let's go to here. Also there you see the copies all work. So there I have to do this one more time as well. U and U. D36. Done. Now we can go to the end. And for example, if I go back to this one and say, well, maybe this fillet is too big. Let's say 0.1. Okay, there you see every part got updated. Or if I want to go back to 0.25, there. If I would even want the tabletop to have the same fillet as this one, then I could go to this fillet and there type in D36. Okay, and this basically concludes everything I wanted to show you in terms of how to maybe explore a design and then create all the different parts, create sketches on construction planes, create sketches on objects, use the mirror command to create symmetrical elements, so you only have to create it once, and then in the timeline at the appropriate position, add some final features, for example, or details like edge roundings. And then in the next video I can show you how we can refine the design. For example, we do not have any joinery. Also, I would like to show you how we can readjust, for example, the timeline and move elements around so we can optimize actually our design. And then in the third video, I will show you how we can create components. So a component, for example, is one table leg. We only need this component once because all those other legs are copies. And then based on those components, then we can create all the technical drawings we have to give to a factory to produce, for example, the furniture part. And then this first introduction video session will give you a good brief understanding what it means, how to design and explore and then produce a piece of furniture in a parametric work environment like Fusion 360 offers you.